All right, hi everyone. We're going to go over Unit 1, Lesson 1, the cumulative practice problems for Geometry 1C. So, starting off, we have a diagram here. Here's a diagram of a straight edge and a compass construction. C is the center of one circle and B is the center of the other. Explain why the length of segment BD is the same as the length of segment AB. So I'm going to highlight a couple things here because it's asking me to identify some pieces. I like to use green as my highlight just because it's a little easier to see than yellow sometimes. So they want BD and AB. So BD is here from B to D. And then they also want AB, which is here. So I'm going to highlight in two different colors, I guess. So, what can we say for our explanation? Well, I noticed that both of these are actually a radius of circle B. And the radius of a circle is a constant length. It doesn't change. So um, the two segments are both radii, which is the plural of the word radius, of the same circle. So they must be the same length. Okay, let's take a look at question 2. Claire used a compass to make a circle with a radius the same length as segment AB. She labeled the center C. Which statement is true, and explain how you know. So we're going to choose which statements are true and then actually provide an explanation next to it. So we're looking here at segment AB. That was the length of the radius of our circle. Now we have a couple pieces here. We have some inside the circle at CD. I meant to use my laser pointer here at CD. We also have CF, and then we have a tiny segment EF. So our first statement says AB is greater than CD. Now AB is the radius, and we can see that AB should also be the same as FC. CD doesn't actually reach to the outside of the circle. So even though we don't know how long each of these pieces is, we can compare them in length. So actually, yes, this first answer is true. We're going to look at all the other ones and then we'll provide an explanation. So the next one is that AB is equal to CD. And if AB is my radius, the only thing that it could be equal to is going to be CF because that is also a radius, which means it connects to the center and the outside of the circle. So can't be that one. Is AB greater than CE? Well, CE extends past the border of the circle, which means that it would have to be greater than AB. So this is actually also incorrect. AB cannot be bigger than CE. And then is AB equal to CE? Well, it cannot be because it's going to be equal to CF. It's the only piece that it's allowed to be equal to here. So we're going to say AB is greater than CD, and our reason here is that A, B. I'll write this actually in a little smaller, finer print so I can fit more of it here. AB is the radius, length. CD does not reach the edge of the circle, so it must be shorter than the radius. Okay. Now let's take a look at question number 3 down here. So for question 3, it says the diagram was constructed with straight edge and compass tools. Points A, B, C, and D and E are all on the line segment CD. So we want to name a line segment that is half the length of CD. So it appears that we have 3 circles here. And from the center of each circle to the edge is a consistent length, because I have this circle here centered at B that has that edge I just highlighted in yellow. So this has a consistent radius, and that distance is going to be AB. That's also going to be the same distance here from B to E. And because I have 2 other circles constructed with radii that are the same, I now know that ED should also be the same, since it's going to be congruent to BE, or equal to. And then for my third circle, centered at A, this one also will have a radius that should be the same length over here at CA. So even though we don't know what these lengths are, we can name a segment that is half of it, because any 2 of these will make up half of the length. So we have a couple different options here, but we want to go in a straight line from left to right. So in that case, we have several options. We can essentially go from the side of the green circle to the side of the green circle, or from the side of our yellow circle to the other side of our yellow circle, or from one side of the blue circle to one side of the other. So those are your possible letter combinations. I'm going to use circle CB. It's I'm sorry, that's the incorrect way to name that circle. I'm going to use the circle that has points on the edge at C and B. So this is called circle A. So I'm going to say that my points here are C, B. And I'm going to describe CB is half the length of CD, which is the entire thing, because we'll say the 4 segments shown are all the same length and CB is 2 of those 4 segments. Now, I know that my description here is not the most mathematical and the most academic of vocabulary. I encourage you to write this in a way that you understand while trying to use the most mathematical vocabulary that you can. Um, so my answers will generally be a little bit of a blend of the two, but since I'm also verbally walking you through it, use your own judgment on how to actually answer these because, like I said, some of your answers are going to vary. We only have one question left. So this is problem number 4, and that is on our next page. So this diagram is constructed with straight edge and compass tools, and A is the center of one circle. So I have A here is the center of one circle. C is the center of the other, so I'm going to label that one, I don't know, blue highlighter color. The two circles intersect at point B. Now it says label the other intersection point E. So they intersect at point B. So point B for us, that's this one down here. Now we want to find the other point where these two circles intersect, and that is this one right here, where those two circles cross each other. So let's label that E. Okay, so now how does the length of segment CE compare to the length of segment AD? So I'm going to actually draw in a little segment here so I can kind of visually imagine it. I want the length of segment CE, and then I'm comparing that to segment AD. Well, AD goes from one side of my circle to the other, so it actually contains 2 radii, one here and one here, where CE is a single radius. So that means that just like our previous one, where we had 2 pieces and 4 pieces, we now have 2 pieces versus 1. So we can say that CE is half the length of AD. And there we go. That is actually the end of homework assignment 1-1, aka Unit 1, Lesson 1.